the most important part of the CCDA Nugget series on design? Remote access. No, wait a minute. Wait. No, it was security. No. It had to be voice. Wait a minute. Data center. Now we arrive at another competing nugget. Yeah, one of the many reasons why this nugget series here at CBT Nuggets is so popular, we're going to look at designing for another immensely important, very popular technology today, and that's wireless. In this very interesting and very important nugget, we'll take a look at the Cisco Unified Wireless Network Solution. We'll see the technologies and the components that Cisco has assembled for next generation wireless infrastructures. We'll look at one of the stars of the show in great detail. It's the wireless LAN controller. And then we'll wrap up talking about how we would go and design wireless networks that are governed by that wireless LAN controller. This is going to be a really popular nugget, all kidding aside, and that's because this is brand new types of technology, and many students tell me that wireless technologies, especially Cisco wireless technologies, is something that's really foreign to them, something that they really struggle with. For example, Cisco teaches some of this material in their switch training as part of their CCNP routing and switching track, and many students tell me it's absolutely the worst part of their CCNP experience for them. What happens a lot of times, unfortunately, is they get stuck with an instructor teaching that material that really doesn't have any experience with Cisco Wireless. And they're a little bit uncomfortable, the instructor themselves, that information is part of the routing and switching curriculum. So we are going to really pull back the curtain and shed great light on this subject for you. I think you'll really enjoy it. When it comes to Cisco's approach to building a real robust, highly functional, highly scalable, very efficient, very pleasant to be around wireless network, they identified 5 major areas that they would really dedicate to product development and that we need to think about when it comes to design. The first is mobility services. Right when you offer wireless infrastructures to your people, they're going to want to do what you would expect them to want to be able to do, and that is roam. I'm reminded of the great B-52s song, Roam if you want to. All right, enough of that. So yeah, they want to get on your network with their device, and they want to move throughout the facility. Maybe go outside, go to the break room, go to another office, go to another building, and they never want to lose that connectivity. So we'll talk about technologies that allow great mobility in the Cisco Unified Wireless Network. We need strong network management capabilities. After all, this is sophisticated technology that we're dealing with. A lot could go wrong with this technology, so we want to make sure we have a robust set of network management tools to help us. We also want to bring the networks together. We want to unify the networks. What does this mean? Well, we certainly want an AP out there sending a signal for people to access network resources. And in order for them to get to those resources, we need the wired network to be connected. So we want to go from wires to no wires. We want to be autonomous in life. Don't we want to be independent? Yeah, this sounds like a good thing. But no, in Cisco's world here, that would actually be a bad thing. An access point that just has to rely on itself, that's independent, this is a bad thing. This is what we might do for a small office, home office, but for a large enterprise, we don't want the access points to be autonomous. Instead, we want the access points to be what Cisco calls lightweight. Yeah, lightweight access points, which means they can't do a lot of thinking for themselves. They are controlled by other devices, particularly the wireless LAN controller that we're going to focus on in this nugget. So, lightweight APs, even though that sounds like it would be a bad thing compared to autonomous, in a large enterprise, these are the types of access points that we actually want. And then, of course, the last area is our client devices. Sure, we need to make sure that the devices out there that our individuals want to use to access our wireless infrastructure, we need to make sure those devices are going to work properly. And look, I'm not just talking about receiving the signal, I'm talking about being able to adhere to the quality of service, to the security, to the virtualization, in other words, to the VLAN infrastructure that we offer. We want to make sure these client devices integrate into our design as seamlessly and as painlessly as possible. Now, if you have not been proud of Cisco systems in the past, you're probably about to lean that direction a bit more. Cisco does just amazing inventions in the area of networking, and then they end up spurring standards based on the work that they've done. And wireless networking is no exception. Cisco invented the lightweight access point protocol. And you already know what this does, I bet, right? We have a wireless LAN controller, the brains of the operation, and it communicates with one of these lightweight access points. Yeah, the lightweight access point can't stand on its own. It needs the assistance of one of these manager devices. And the protocol for these two to communicate with each other, Cisco invented the lightweight access point protocol. Well, this caught fire, and the IETF created their own standards-based version. It's called Control and Provisioning of Wireless Access Points Protocol, CAPWAP. I don't know if the industry says CAPWAP, but I do, and it's really fun to try. You should definitely try it. So, this particular protocol is the industry standard way for these devices to communicate. Now, what does Cisco do with their equipment? Well, if you have 5.2 wireless equipment or greater, okay, so if you're dealing with wireless LAN controller software of 5.2 or later, then that will go ahead and utilize this particular new standard. A lot of the devices will allow fallback to lightweight access point protocol if your equipment isn't CAPWAP ready. And I want to warn you that some of the latest, greatest new equipment that Cisco is creating has dropped lightweight access point protocol support. So just be very aware of this when you're designing your wireless infrastructure. This is the old Cisco proprietary solution. Here is the new open standard solution. The cutoff point in wireless LAN controller software is 5.2. In other words, go above 5.2 and you might be able to support both. You're guaranteed support for the newer protocol. Okay, you might be able to support the earlier protocol. You'll just have to investigate that as you start getting into code releases higher than 5.2. Now, earlier we pointed out that the enterprise wireless infrastructure is going to want lightweight access points. We said that these lightweight access points were not all that smart. Yeah, unlike an autonomous access point that could stand on its own, the lightweight access point would divide its workload with the wireless LAN controller. This division of workload goes by the name split MAC operation. The access point is certainly doing some stuff, right? Like it's doing 802.11 functions like beaconing the SSID out to the devices. And of course, it's going to be handling responses to these probes from clients. From an 802.11 control perspective, it's doing things like acknowledging packets and transmitting information. From an 802.11 perspective, it's doing queuing of traffic. From an 802.I standpoint, which is the security specifications for wireless, it's doing things like encryption of data. So, the access point isn't all that unintelligent in an enterprise lightweight environment. It's doing some stuff. But notice the controller is going to be very, very active. For instance, from an 802.11 perspective, it's doing management. Yeah, it's doing management of particularly associations. Yes, it's going to be responsible for actually associating particular clients with the lightweight access controller, lightweight access point that it is working with. From an 802.11e, from a QoS perspective, it's going to be handling resource reservations. Yeah, so it's going to be doing reservations of resources on behalf of the access point. And what about 802.11i? Well, it's going to be actually doing the authentication and the key management. So, notice from a security perspective, the access point is doing some stuff, the wireless LAN controller is doing some stuff, and it works this way throughout the various standards and the various responsibilities that each of these devices has. Again, we term this split MAC operation, and it's a division of labor in an enterprise between the access point and the controller. Do you remember the language of love that is going to be spoken between these two to make all this possible? Sure, the new open standard that we are moving to is, of course, CAP WAP. Now, whether you're dealing with one of the autonomous access points from Cisco or you're dealing with a lightweight access point from Cisco, and that's certainly our emphasis, they are really remarkable devices, especially your lightweight ones, considering that they're able to split the workload with the wireless LAN controller. There are many access point modes that are possible. Now, the main mode that you're going to be dealing with most of the time is what's called local mode. And the access point is just acting like a traditional access point in this default typical mode. But there's also HREAP. What HREAP is all about is hybrid remote edge access point mode. So when you do this particular mode, you have a wireless LAN controller that is like at headquarters. You have a WAN link, and then you have a remote branch office environment, and that's where your AP in HREAP mode would be operating. Wow, pretty amazing. So it's still able to function with its wireless LAN controller even though it is separated by a WAN link. If your access point is in rogue detector mode, wow, guess what its job is? It's to play detective and look for any unauthorized rogue access points that are out there. Pretty cool. Now, it can't do anything about those rogue access points in that mode other than just alert you to their presence, which I suppose is good enough. But what if you wanted the access point to not only detect them, but literally help you unregister clients to that rogue access point? Well, that's what monitor mode is all about. What if you wanted your Cisco access point to become a packet capture utility for you? Yeah, literally to sniff packets off the radio frequency airwaves. Well, that's what sniffer mode is for. And finally, what if you need your access point to connect other access points? Maybe you have one building and you want to go ahead and connect that building to another building. Well, this is when you put your access point in what is called bridge mode. So, there are plenty of modes of operation for modern Cisco access points, and we have now mastered 6 of those. Now, we spoke about it earlier, something that we're going to want to do in most enterprise environments, and that is to kind of unify the wireless to the wired network infrastructure. Keep in mind, in an autonomous network environment, and that would be for smaller environments, the bridge between those entities is indeed going to be the autonomous access point. Yeah, you're going to have clients out there that are consuming the wireless infrastructure. The access point is going to connect to your wired traditional switch infrastructure, and it is going to be the bridge between those two architectures. Here, we will literally be taking traffic from the clients and putting them into VLANs in the wired infrastructure. In our lightweight environment, what we're going to do is we're going to have the wireless LAN controller be the bridge into the traditional switched infrastructure. It's going to be trunking the VLANs into that infrastructure. It's going to be communicating wirelessly with the access points, and they'll be picking up the client signals. So you notice what device bridges your traffic into the wired infrastructure is going to vary depending on if we're in the smaller, kind of unmanaged autonomous environment or if we're in the more sophisticated, lightweight access point environment. Now, just really to drive the point home about how sophisticated the wireless LAN infrastructure is, on a lot of your Cisco devices, you might have like a console port, an aux port, and then the fast Ethernet ports that are going to make connections out to devices. On a wireless LAN controller, we have quite a few interfaces. There is a management interface. And what's the management interface all about? Well, that's for in-band management things that the wireless LAN controller will need. A great example would be communicating with a AAA server. Then there's the access point manager interface. What's that all about? Well, that's of course for communications with the access point. Then there's what we call a dynamic interface, and this is to receive the actual wireless data. Yeah, the information that's coming from client systems. Then we'll have a series of virtual interfaces potentially, and this is for various purposes like DHCP. Another big one would be for particular security functions. And then there's the service port interface, and this interface is for out of band management. So when we want to come in and do particular management tasks on the wireless LAN controller and ensure that that traffic is completely segregated from the data traffic of clients and segregated from the access control point or access point traffic, we use this service port. Now, you're probably wondering about just how big this very awesome, lightweight, wireless LAN controller environment can become. Well, let me give you an example. On the 4400X series of wireless LAN controllers, we can support 48 access points per port. What port are we talking about? We're talking about that AP manager port, right? That port that is responsible for managing the access points. Now, believe it or not, that's not going to be big enough for some environments. You might think, well, 48 access points, that's amazing. Well, there are massive wireless LAN infrastructures out there where that's not enough. The solution? One of two things. Obviously, make sure you invest in a wireless LAN controller that has multiple AP management ports. So now you can do 48 on one port, 48 on another port. And there's even a link aggregation feature. So we can go ahead and aggregate links to work together to scale to an even higher number of access points. So the Cisco wireless LAN controller solution isn't really handcuffed when it comes to scaling to massive numbers of access points. So, what an amazing symbiotic relationship between access points, the lightweight variety, of course, and the wireless LAN controllers. When the APs come online in this type of an environment, they immediately get their firmware updated if the wireless LAN controller tells them that their firmware needs the update. And I don't know if you've noticed, but with wireless equipment, firmware updates are very, very common. There's all kinds of enhancements and changes going on all the time, so firmware is a constantly updated component. The wireless LAN controller beautifully, efficiently provisions the SSID for the wireless LAN, the quality of service settings, the security settings, and of course, at various times during their life together, the wireless LAN controller will be querying the access point for various pieces of information. The access point turns right around and sends heartbeat messages using the CAPWAP protocol to make sure that the wireless LAN controller is there and able to continue to service the needs of the access point. Now, earlier we talked about just how important it is for clients to be able to seamlessly, efficiently, roam around your infrastructure and maintain communications without a hiccup on the data network. This is a capability that is made pretty simple in wireless LAN controllers thanks to mobility groups. We take the wireless LAN controllers that are going to feature this roaming capability and we make them part of the same mobility group structure. Now, there are three types of roaming that I want you to be familiar with. There is intra-controller roaming. This is very simple to pull off, and this is the recommended way in which to offer roaming to clients. What you have is you have a wireless LAN controller and you have a bunch of APs out here, of course, right? We know there's up to 48 of them on one port. And what you're having the client do is just roam from AP to AP, all, of course, managed by the same wireless LAN controller. This is what we mean by intra-controller roaming. Now, that might not be good enough for some environments. We may want to step it up and we may want to offer inter-controller layer 2 roaming. This is not all that bad of a feat to pull off, right? Because what we're going to do is, sure, they are going to roam across two different wireless LAN controllers, but these wireless LAN controllers are in the same IP subnet. That's why we call it layer 2 inter-controller roaming. It's within the same IP subnet. Now, you have already guessed what inter-controller layer 3 roaming is all about. This is the most challenging to pull off. This is where the most number of things could go wrong. This is going between wireless LAN controllers that are in different IP subnets. Again, the most challenging design with the most areas of potential fault. Now, just like spanning tree protocol can be the biggest area of problems and headaches for administrators when they are designing the layer 2 infrastructure in an organization, roaming can certainly be one of the biggest areas of problems for our designers and our implementers in the wireless world. Let me give you 4 key design recommendations for you when it comes to this topic of roaming. I already alluded to it. Try and minimize the amount of inter-controller roaming that your individuals have to do. If you are going to be doing a lot of inter-controller roaming, try and keep it that layer 2 variety where you're not jumping between subnets. When you're going to do the inter-controller roaming, try and make sure there is 10 milliseconds or less of round trip time for communications between those wireless LAN controllers. So make sure we've really optimized the connectivity between those devices that individuals will roam between. Also, take advantage of something called Cisco Centralized Key Management. This is a standard that Cisco supports for allowing the wireless LAN controllers to associate with each other very effectively and efficiently, and also clients roaming between them. And finally, roaming is something that really has a lot of variety in how it's implemented by different vendors. So if you're going to have a whole bunch of different clients out there supporting various vendors' wireless technologies, make sure they support the Cisco Compatible Extensions program. This is going to help guarantee that those devices are going to be able to function in your primarily Cisco environment with a minimum of problems. Now, when you think about the overall design, right, of this complex wireless infrastructure that we can build with Cisco, you realize how very important the wireless LAN controller is. And you should be nervous. You really should about single points of failure. So you want to design a redundant wireless LAN controller type environment where an access point could join and could meet up with and could be serviced by some other wireless LAN controller in the infrastructure. Well, there's three ways this can be carried out. First, you can go to the access point and you can program it with different redundant controllers. Yeah, we have what's called a primary. So you tell it, okay, you have a primary controller you're going to work with. Then you can set up a secondary. Then you can set up additional what are called tertiary access wireless LAN controllers. Pretty cool. So this is the deterministic model. You program these settings into the access point and it will follow them using its primary unless the primary goes away, and it'll cut over to the secondary. There is a design here, or in a mode I should call it, called initializing. This is what you initially do with the access point. There's a wireless LAN controller that is the master that you've configured for the AP. It will connect to that master device, and then you can go ahead and feed it information about secondary and tertiary redundant controllers out there. Finally, there is a mode we can operate in called dynamic. When you are in dynamic mode, your access point will dynamically attempt to join the wireless LAN controller with the greatest availability for access point associations. The least loaded wireless LAN controller will go ahead and be selected dynamically by the particular access point. Now, as you might guess, one of the most popular ways to do this redundancy is that deterministic approach. Pretty popular because it's pretty darn easy to implement. You are dictating, hey, look, you access points over here, use that wireless LAN controller right over there as your primary, and hey, there's one over there in another location that you can use as your secondary. With deterministic redundancy designs, we often hear these N plus modes that we can operate in. For instance, in N plus 1, you have one wireless LAN controller that is backing up a different number of primary wireless LAN controllers. This could be 1, it could be 2, it could be 3, it could be 4. So anytime we see the N here, it's to stand for any number of wireless LAN controllers. What's the potential problem here in this design, of course? Well, if you have a bunch of your primaries fail, you could oversubscribe the one wireless LAN controller that is intended to act as backup. How about N plus N? Well, you got it. We have any number of controllers being backed up by a number of backup controllers. Notice we're getting more budget here, aren't we, for redundancy in an N plus N type of design. Finally, the N plus N plus 1 design says that we're going to have any number of wireless LAN controllers backed up by a number of wireless LAN controllers, and as an added safeguard, we'll have one act as a tertiary. So pretty interesting. We've got multiple levels of redundancy here, and all of it falling back to just one single wireless LAN controller that is the ultimate kind of last resort from a redundancy standpoint in the wireless LAN controller infrastructure. Something else that our Cisco Unified Wireless environment can do, thanks to our wireless LAN controllers and our lightweight access points, it can do radio resource management. What does this mean? It means the capabilities of the equipment allow it to dynamically do channel assignments. Yeah, so we can have the SSID jump to a different channel dynamically. Interference can be detected and, most importantly, avoided in the infrastructure. Power control can be dynamic, so we can have the power increase on antennas and decrease dynamically. Coverage holes can be detected, okay, so problems with coverage can be handled, and client and network load balancing can be implemented thanks to this particular feature. So radio resource management is very important, and it hinges on a capability in Cisco equipment called radio frequency groups. So in order to pull off that really cool radio resource management calculations, what happens is lightweight access points periodically send out neighbor messages through the radio frequencies. This includes an encrypted shared secret. We configure this, of course, on the wireless LAN controller, and this gets pushed out to all of the access points. Access points that see this same shared secret with each other will literally validate this, and they'll ensure that their signal strength is at a minimum acceptable level for them to form one of these radio frequency groups. What happens next is the wireless LAN controller will elect a group leader or master of that particular radio frequency group, and it will be responsible for analyzing real-time radio data that's collected by the various systems and calculating the master power plan, like we said, the channel allocation. So, very, very sophisticated capabilities here to try and ensure that the wireless local area network does not fall victim to issues like poor coverage and interference. So at this point, you're completely excited. I mean, you are very educated. Congratulations on the Cisco Unified Wireless solution. Awesome. You're ready to go ahead and bull forward with the design. But be careful. Before we can complete this design for our customer, we want to do a radio frequency site survey. Yeah, we want to first look at the requirements of the particular customer, right? We want to look at things like what exact sites do they want covered? What are the levels of service that they expect? What kind of applications are they going to try and run over this wireless infrastructure as opposed to the wired? Look at things for conference rooms and maybe areas that'll be problematic, like a particular test lab that's in steel, to protect it from other areas. Things like this have to be looked at. We want to look at the overall areas of coverage and the user density. No, we're not insulting the users by calling them dense. How many users are there going to be in a certain area? Third, we want to look at where the client thinks the APs should go. And we'll want to be using the product guide from Cisco as we look, because if they expect an access point to be hanging from a light pole 50 feet in the air outside in Michigan, we need to make sure that this access point is of a grade that can handle such a location. Fourth, we're going to actually perform the survey. Yeah, we're going to go ahead and make sure that we test how the access points are going to do in their proposed locations. And obviously, we want to build careful documentation on our findings for this important site survey. Are you going to have a lot of options for access points, for wireless LAN controllers, once you decide on where they're going to be placed? Yeah, you certainly are. Let's go up to Cisco.com. Let's go to Products and Services, and let's choose Wireless. We'll go to Access Points, and here we see some featured products. Here's the 3600 series access point. Notice this is the first access point to do 802.11n, and it supports 4x4 multiple input, multiple output antennas for better performance. Yeah, this thing is obviously going to be impressive. And then lower end devices like the Aeronet 600 series Office Extend. Okay, so this is a lower end device. Notice speed setup time without the need for technical support with no touch deployment. We're obviously talking about an autonomous type of AP. By the way, probably should have mentioned this earlier. Some of the access points available from Cisco are going to be capable of autonomous or lightweight operation. So with some of the APs, we'll literally have the choice. What about our wireless LAN controllers? Well, plenty of options there. If we start back to the main wireless page, we see wireless LAN controllers, and sure enough, lots of options. We have 8500 series controllers, 5500 series controllers, 2500 series controllers. We even have options. If we go to the All Products tab, there is even options for wireless service modules. Yeah, isn't this interesting? So we can go ahead and have a CAT 6500 series running a wireless service solution inserted into that chassis. So plenty of options when we are designing the wireless LAN infrastructure. Now, let's wrap up with just two last topics that I want you to be aware of that you might consider designing for a particular client. One has to do with guests. Yeah, inevitably, someone's going to come to you and say, can we set up a safe and secure way in this amazing wireless infrastructure you set up to accommodate guests? And the traditional answer was, oh yeah, no problem. We'll set up a guest VLAN for those individuals. We'll do a lot with security to make sure this guest VLAN can't penetrate the rest of the network infrastructure. Well, good news. There's a more flexible, greater way to do this thanks to the wireless LAN controllers and the language of love that they speak with their access control or access points. It's called an Ethernet in IP tunnel, and it allows us to logically segment and transport this guest traffic between the various access points and most particularly between the various wireless LAN controllers. No need for a guest VLAN in this case. All we got to do is make sure that this Ethernet in IP tunneling solution for guest traffic is supported across all of our wireless LAN controllers. And if they're modern Cisco devices, we obviously shouldn't have a problem with that. And now we have a robust, simple solution for guests on the network. By the way, they're going to be sharing the same radio frequencies with our regular users that are having their traffic go to VLANs in our wired infrastructure. So this is a very cool ability to take our guests and protect that traffic in an Ethernet in IP tunnel. Now, the last topic that we want to present for you that who knows, maybe someday you're responsible for designing, is an outdoor mesh type of solution. Have you heard about cities now that are completely free Wi-Fi? Yeah, this is starting to happen. Or maybe a massive park. Think about something the size of Central Park in New York. And there's going to be this free Wi-Fi throughout the entire infrastructure. So that if you see some plant life or if you see some animal that you want to identify, you grab your wireless device and play online poker. All right. Well, in all seriousness, this is quite a challenge, right? To make sure there is very high quality wireless connectivity no matter where we are in this large outdoor environment. Well, this is something that Cisco addresses head on. They have a wireless control system that will be in charge of monitoring and managing this. It works in conjunction with wireless LAN controllers. It works in conjunction with something that's called the root access point. This is typically on a rooftop or a tower, and it is in charge of the mesh access points. So the outdoor mesh solution involves 4 ingredients: a wireless control system, our wireless LAN controller or controllers, our root access point, and our mesh access points. This builds a highly efficient, highly scalable, and most importantly, highly redundant type of environment. In a mesh environment where all of these access points are everywhere providing coverage, you never know when various access points are going to fail. And the root access point and the mesh access point and this background intelligence of WCS and WLC make sure that no matter what happens in the environment, other access points seamlessly pick up the slack. So in this CBT Nugget, we explored the wonderfully exciting, hugely interesting world, at least I hope you feel that way, of Cisco Unified Wireless Networking. What was one of the huge stars of the show? The wireless LAN controller. That's right, it wins the Oscar for perhaps the most unique device that really shines when it comes to an enterprise wireless infrastructure. We wrapped up this nugget with talking about some particular design concerns. Things like doing a proper site survey and even designing some of the newest technologies in wireless like new and improved tunneled guest access and outdoor wireless mesh networking. Well, I hope this has been informative for you, and I'd like to thank you for viewing.